Hi everyone, welcome to my channel. I am Dr. Shehbaz here. So in this video, I will perform factor analysis using principal axis factoring method. So factor analysis help us examine whether a set of questionnaire items can be represented by a smaller number of underlying factors or constructs. So in this video, we will focus on the most important outputs KMO and Bartlett test, commonalities, factor loadings, and the rotated factor solution. So we are going to perform factor analysis using principal axis factoring method in SPSS. So we will click on analyze button and then click on dimension reduction, then click on factor. Okay, so we have three variables and each variable has four survey items. So you can see first one, green compensation and reward, 4 items. Green employee involvement has 4 items, and green performance and management has 4 items. So each variable has 4 items. So we need to select all items and then put in variable set and then click on descriptive statistics. We will click on univariate descriptives, coefficients, significance levels, determinant, KM and Bartlett test and click on continue. Then we will go to extraction. So this is the most important thing to do because in the previous video we did factor analysis using principal component method. Now we are going to do factor analysis using principal axis factoring method. So now based on eigenvalues greater than 1, but we have three factors, so we need to specify it as 3, and we also need Scree plot to see the eigenvalues on elbow line. Now we click on continue. Now we come to rotation. So this is also very important aspect regarding factor analysis. In the previous video we did principal component factor analysis and we selected varimax because our factor was unrelated. But now we see that these all variable factors are related to each other. So it means we are going to test principal axis factoring method using direct Boolean method. So now we will click on continue and score, continue, and then click on OK. So we get the results by applying principal factoring axis method. Okay, so we have descriptive statistics, mean value, standard deviation for each measurement item scale. On the other hand, we see the correlation matrix for survey item. You can see there is a perfect correlation between the same item. It always one between the same item, but we need to see this one with other measurement items. You can see GCR with a strong correlation between two, GCR1 and GCR2. Also strong relationship between two. Also there is a good relationship between 4 and 1, and you can also see the significance level below. Okay, so now we come to the KM and Bartlett test. So you can see Kasser-Meyer Olkan measure of sampling adequacy is 0.930, which is higher than 0.6. So it means the adequacy of our data is good. On the other hand, we see the Bartlett test of Sphericity. The value of P is significant. I mean the value of P is less than 0.05. So in both cases, we see the suggested value of KMO of Kasser-Meyer should be higher than 0.6. Okay, in case of Bartlett test of Sphericity, the P value should be less than 0.005. 5. So in both cases, we can see that the value of KMO is higher than 0.6 and the Bartlett test of Sphericity p-value is less than 0.05. So in both cases, we can see our data is good for further analysis. So we remove the color here. Now we go next table. Okay, so these are commonalities. Basically, commonalities show the variance explained by retained factors. So we have three factors, so you can see the variance explained by retained factors. Okay, now we total variance explained. So we have three factors in our data, and you can see all three factors explained 67.716% of total variance. And now we come to Scree plot. We can see here eigenvalue 1 and elbow shape. So you can consider first factor and the other indicators, observed indicators. So only one eigenvalue run from to other eigenvalues. So these are good Scree plot observed variables rather than this one. Okay, now we see the factor matrix where we see the factor loading of each survey item. You can see 0.703 for GCR1, 0.694 for GCR2 as well you can see here. So it means the all factor loading of each measurement item is higher than 0.5 as per suggested by Hare et al. 2019. The value of factor loading higher than. So we have done